Hello again. So today we're going to look at a simple problem. Again, it looks like it'd be kind of hard to do, but it's really not. A rocket is fired upwards with an acceleration of 30 meters per second squared. If the 200 kg rocket experiences air resistance of 6,000 newtons, what is the thrust force provided by the engines? And again, the simplest thing again to do is draw a free body diagram. Ask yourself, what are the forces that are acting on this rocket? And we know that there's a force pushing it up, and they called it the thrust force. I'll just call it FTH. I'm making it big because it's going to go up. And then what are the forces that are going to be acting against it? And when I'm falling, the air resistance acts upwards because it's always opposite to the direction that your speed is or your velocity is. But in the case of an object going upwards, obviously the air resistance would be, I hope you'd say, downwards. So there'd be an F air downwards. And then, of course, it's the rocket's own force of its weight, which is Fg, which is W, which is mg. And that's the weight of the object, and that's what the free body diagram looks like. If you can think of any other forces, I'd be glad to consider them, but I think that's about it. And so again, our steps are really simple. We're going to take this free body diagram starting from the dot and write all the forces. It's only in the y direction, so I have 1 plus force and 2 minus forces, so I have FTH, it's plus. I won't put a plus in front of it, minus F air, minus Fg equals ma. That's it. I'm going to rewrite this and replace the Fg with an mg equals ma. And that here, oops, is your rocket equation. So anytime you have a rocket going up with just air resistance, this is your go-to equation. And it's not really something I want you to memorize. You should be able to just make this free body diagram and just pop this right out from there, where all the pluses are pluses and all the downs are minuses. If it was right and left, the left would be negative, the right would be positive, and that's all there is to it. And so now, all I do is I say, okay, well, now I can solve for the thrust first. So FTH is going to equal to, I'll take those two guys to the other side, F air plus mg plus ma. And so you got to think about this. It makes sense that the force of the rocket should be greater than the force of air resistance, gravity, and plus be able to give it this boosty acceleration. And so if I just plug in the numbers, FTH is going to be F air, which is 6,000 plus 200 times 9.8 plus 200 times 30. And so that's 6,000 plus, that would be what, 1960 plus 2, that'd be 6,000 more. And so the force thrust would end up being, so add all these up, so that's 12,000 plus 1960, which is what, 13,960 newtons. So that's the force of thrust that the rocket must provide so that it can get that kind of acceleration for that heavier rocket when there's so much air resistance. We see that it all just popped right out of here. I could have given you the thrust of the rocket and said, hey, how fast is it going to accelerate? And so you'd be looking for this guy instead of that. Okay? So I hope that makes sense and helps you with your forces in vertical motion. Bye for now.